This is our second goal. And we will evaluate a numerical expression by using rules for exponents. Let's see where this can be useful. Back in the days, before calculators, you got to do these things by hand, and we're going to do part of it by hand. Find $1,920,000, a suitably big number, times 0.0015, all divided by 4 zeros, 3, 2, so something that would require a lot of counting to get the right name for the fraction, times 45,000. This is a little bit inconvenient to work with, so what we'll do is we'll write it in scientific notation. And then we'll do some arithmetic. Well, I'm going to be moving the dot, the decimal, from the end of the 1,920,000 here between the 1 and the 9. So I will have 1.92 times 10 to some power. I'm going left, and I'm going left. This is another way to do your counting. 1, 2, 3, 4, 5, 6 places. So that's going to be 10 to the positive 6 power. Times. Well, I'm going to want my decimal between the 1 and the 5 to the right of the first non-zero digit. And I'm going to have to move 1, 2, 3 places. So that will be 1.35, pardon me, 1.5 times 10 to the negative 3 power. It started out as a fraction, so we'll have a negative power. Move to the right, we'll have a negative power. Whatever way of remembering it works for you. And aiming for 3.2 times something. And that something will be 10 to the 1, 2, 3, 4, 5, negative 5 power. And then for the 45,000, our caret goes to the right of the first non-zero digit. 4.5 times 10 to the, starting at the end, 1, 2, 3, 4, positive 4th power. The usefulness in this is all those inconvenient zeros are now tied up in 10 raised to some power, and I've got a bunch of them. These are just exponentials. They all have the same base, and I'm going to get to use the product and quotient rule on it. The rest of these numbers I'm actually going to have to work with as they are. So let me group them together. That's our second move. Let me get that back on the screen. I can do this. There we go. So I'll just write the 1.92 times 1.5. And that's going to be over 3.2 times 4.5. And that is, on the top, we've got 10 to the 6th times 10 to the minus 3. And grouping things on the bottom, 10 to the minus 5 times 10 to the 4th. This piece, any sane person will deal with their calculator if they're allowed to use it, which you are in this day and age, and comes out to be a very convenient 0.2. This other piece, seems to me I misplaced a pen. That's okay. This other piece will combine the product rule and the quotient rule, and we'll have on the top And let me just write it out with the top and the bottom. We'll have 10 to the 6 minus 3, and on the bottom we'll have 10 to the negative 5 plus 4 power. Point 2 comes along for the ride. And we'll have, well, now on the top we have 10 to the 3rd, and on the bottom we have 10 to the negative 1. We can either use the definition for negative exponents and bring this 10 to the negative 1 to the top, or we can simply subtract, and we'll have 10 to the 3 minus a negative 1. You could also have done that directly at the beginning, add the top and subtract the 2 powers from the bottom. And that's still times 0.2. But when we subtract a negative, of course, we're going to get a positive. So we'll have 0.2 times 10 to the 4th power. And we could rewrite that in standard form. Right now it's not in really proper scientific notation because the decimal's in front of the non-zero digit. But it's a small enough power we can just rewrite that in standard form. Take our 0.2 and go 1, 2, 3, 4 places to the right. Decimal now is at the end of the number. Fill in each hole with a 0. We have 2,000. Again, we have to move the decimal to the right here because we're undoing a positive exponent.